Angles and their measures. What we're getting into is we're getting into trigonometry now, and we need to get a little bit of background information before we can really get into talking about trigonometry. By the way, trigonometry is more than just the sine and the cosine and the tangent that you learned in geometry. It's a lot more. And that's why we're going to look at the basics of angles first. And the measure of an angle is determined by the amount and the direction of rotation from the initial side to the terminal side. If the rotation is in a counterclockwise direction, that means you start at 12 and go 12, 11, 10, 9, counterclockwise direction. The angle formed is a positive angle. And consequently, if we go in the clockwise direction, if we start at 12, 1, 2, 3, 4, then if the rotation is in the clockwise direction, then the angle formed is a negative angle. So let's take a look at our two pictures here. And what we have down here in the pictures, first of all, is, notice, the initial side of the angle is along the x-axis, and then the terminal side actually ends up to be over here in the second quadrant, and we're measuring. You can see by the arrow, we start and we measure over there. We're going in the counterclockwise. When we draw our arrow, we're going in the counterclockwise direction. That means that whatever theta, that is this circle with the line through it, that's not a very good one. Let's try it one more time. A circle with the line through it like that is measured with a positive value. The other side of that is we can still start over here with the initial side along the x-axis, and it's always going to be along the x-axis. If we go in the clockwise direction over here to the terminal side, which ended up to be in quadrant 3 here, our angle of theta is negative because we went in the clockwise direction. If our terminal side of the angle lies on one of the axes, on the x-axis or on the y-axis, it is called a quadrantal. Quadrantal. One more time. Quadrantal angle. So the values of the quadrantal angles are 0, 90, 180 degrees, 270 degrees, and 360 degrees. But just to talk about one more time here, if we look at picture A, once again, the initial side of the angle is along the x-axis, the terminal side is in the second quadrant. We're measuring our angle in a counterclockwise direction, so we have a positive angle. And again, the only thing to point out on this one is that our theta is a positive angle in quadrant 2. In example B here, theta lies in quadrant 4, but once again, our initial side is along the x-axis. Our terminal side is in the quadrant 4. And I know that when we talk about the value of this angle, we're going to call it negative, because when we measured here, we went clockwise. And finally, in example C here, our initial side is over here on the x-axis. Our terminal side is on the y-axis. And whenever our terminal side is on one of the axes, that is when we have a quadrantal angle. Angles can be measured in two different ways. They can be measured in a way that we're used to, which is in terms of degrees, but they can also be measured in a way in terms of radians. And this is where you might want to get your highlighter out, but degrees measure the angle. So let me highlight here and then try to say this again. But degrees measure the angle created by the terminal side and the initial side. Radians measure the length of the arc created by the terminal side and the initial side. So we measure angles just like we did in geometry, but radians are measuring the length of the arc. Finally, the last two important words here to talk about before we actually get into the mathematics is a reference angle. And it's one more highlight-worthy term. A reference angle is an acute angle. An acute means that it's going to be between 0 and 90 degrees. Between 0 and 90 degrees, not 0 or not 90. Formed by the terminal side and the x-axis. And then coterminal angles are two angles drawn in standard position that share a terminal side. In other words, they have the same position, but a different amount of direction or rotation to get there. And I want to go back to one of our examples here on 2A for a minute and just look at a coterminal angle. So we have the picture drawn as is there. But what could happen is we could still start with our initial side here, but we could start and go in the clockwise direction. And what I have there in the lavender color is that the initial side is still along the x-axis. The terminal side is supposed to be the same as what's already there. It's just that we measured our angle differently so that they finished in the same place. The value that was already there, that terminal side that was already there, we just went a different direction. Again, let's go back and look at coterminal just to think about that. Coterminal angles are any two angles. So we've got two angles drawn in standard position. They're drawn in standard position and they share a terminal side. So let's flip the page and let's practice with some examples here. It says draw each angle in standard position, determine the reference angle, state the quadrant the terminal side is in, and then find one positive and one negative angle that is coterminal to each angle. So as we start here with this first 225 degrees, if we start here and we go this far, notice that that symbol right now kind of looks like a protractor. And a protractor measures 180 degrees. And then we're going to go a little bit more. So our terminal side is our x-axis here on our x-axis, and then, sorry, our initial side is on the x-axis. The terminal side is here. And we measured in the counterclockwise direction so that we have a positive angle. What we want to know now is, well, what's our reference angle? And remember that a reference angle is acute. More than 0, less than 90 is what acute means. So really the only part that we want to know here is how big is that angle? And if we go back to what we were talking about with respect to the protractor, what happens is we can take the angle that we were given, and we can take out the protractor, which is 180 degrees, and when we subtract those two, we get 45 degrees. Well, what quadrant is that in? In case you're not aware or you've forgotten, here's quadrant 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. So our terminal side is where we're in quadrant 3. Finally, what we want to know is values of coterminal angles. So what has to happen here is we can take the original angle, again, which was 225 degrees, and we can put a rotation in. And we can, to get a negative angle, and actually we can subtract 360 degrees from that. And when we subtract 360 degrees from that, we get negative 135 degrees. Or we can take our original angle and we can add 360 degrees to it. And when we add that value to it, we end up with 585 degrees. I do want to just draw a picture here to remind us that if we're looking at coterminal angles, we start at the initial side, same place where the initial side is right now, but then we would measure from here to here. What's in blue in the picture, that would be negative 135 degrees. If we're measuring in terms of the green here, we would go around and then we would go around again, but we would end up at the same terminal spot. That's what is in green. We went around more than one time around, more than 360 degrees. Well, number 2 says negative 60 degrees. Remember, negative tells us which direction we are going. We are going clockwise in this particular picture, so our initial side remains, but we're going to go here. We went clockwise. What we need to know, because we've drawn our value, our angle in standard position, now we want to determine the reference angle. Well, in this particular case, it's nice because 60 degrees is already an acute angle. Once again, the negative just tells us that we're going in the clockwise direction. So our reference angle, we don't have to do any calculation on this one, we just end up with 60 degrees. Our quadrants, 1, 2, 3, which means that we must be in 4. And then what we have to do to figure out our coterminal angles is we're going to take our original angle, which was negative 60 degrees, and we can subtract 360 degrees, and we end up with negative 420. Or we can take our original and we can add 360 degrees, and when we add that back in, then we end up with 300 degrees. $405 degrees. You're probably kind of getting the hang of things now. But like we saw earlier here, if we look at 405 degrees, we start with our initial side, and we would go all the way around, and then we would go around a little bit more. And our terminal side would end up here. So what happens here is we've got more than one rotation in this picture, because if we go around full circle, as I like to say sometimes, a full circle is 360 degrees. And then we went to 405 degrees. Well, let's look at then what our reference angle is. And what happens is we could take our 405 degrees and we can take out that full circle of 360 degrees, which gives us 45 degrees. Well, we end up then in quadrant number 1, the first quadrant. And then what we want to do is we want to find one positive and one negative angle that's coterminal. And once again, what we do is we take our original angle and we subtract 360 degrees. And when we do, we get 45 degrees. And the thing is, it says find one positive and one negative angle. So if we leave it like that, we haven't really found a negative angle. So let's subtract 360 degrees again. And then when we do, we end up with negative 315 degrees. So 45 degrees is a good angle, but it's not going to give us a negative angle. When we come over here to the other, well, the other one is to take the 405 degrees and add 360 to it. And when we add 360 to that, we're going to end up with 765 degrees. Negative 210 degrees. Again, the negative tells us that we're measuring our angle by going in the clockwise direction. So here's our initial side. And we're going to go from here to here, and then a little bit more. So we end up over here. What quadrant did we end up in? Quadrant 2. And again, if you look back there, the reference angle is a positive acute angle. It connects back to the x-axis. So all that we want to know is that blue part in terms of our reference angle. And what happens is, originally we had the negative 210 degrees. There's that protractor again. We can take out that protractor. In order to do that, I have to add 180 degrees, which gives us negative 30. But again, in terms of a reference angle, we only want a positive value. The negative tells us the direction. So we don't need to write the negative. Only the positive, 30 degrees. Acute angle between 0 and 90 degrees. To calculate out our coterminal angles, we're going to take negative 210 degrees, our value that we were given, and subtract 360 degrees, which gives us negative 570 degrees. And we can take negative 210 degrees and we can add 360 degrees. And when we add those, we get 150. as we flip our page here, we kind of have the hang of things in terms of angles. Now, the reference angle, the quadrants, the coterminal angles. I'm sorry, I got the wrong order on the smartboard here. Find this page in your notes. So remember back to the definition on the front page where radians measure the length of the arc created by the terminal and the initial sides. So a central angle, which goes back to geometry, it's a positive angle whose vertex is at the center of the circle, and the rays of the central angle intersect an arc on the circle. So here's our circle. If the radius of the circle is r, and the length of the arc subtended by the central angle is also r, then the measure of the angle is 1 radian. Again, probably a little bit confusing in terms of words. So the thing that I want to point out, in other words, radians are a way to measure angles in terms of the length of the radius, the length of the arc. So an angle of 1 radian results in an arc with a length equal to the radius of the circle. Still probably confusing. But the circumference of the circle. Anybody remember what the formula for circumference of a circle is? Other one. 2 pi r. The circumference of the circle is measured by 2 pi r. If r is 1, then what happens is we do 2 pi times 1. Then the circumference of the circle is 2 pi. In other words, then, 1 revolution is 2 pi radians. Well, how much is 1 revolution in terms of degrees? 360. Well, what if, instead of going a full revolution, we go half? Just want to go half now. That's all right. Want to go half. So, how much is half a revolution in radians? Yep, it's 2 pi times a half. It's this value times a half. Well, 2 pi times 1/2 is pi radians. And so if 1 revolution is 360 degrees, how much is half of a revolution? 180. Well, now, let's take 1/4 of a revolution. If you like the math here, that means that we're going to take 2 pi, that's a full revolution, and we're going to multiply it by 1/4. Well, 2 pi times 1/4 is actually a half. So that's the radians here, and that's not really a good spot to put that in. But if we only go 1/4 of the circle, how much degrees do you think that is? again, in terms of space here, if we want to go 1/6 of a revolution, what we're going to do, a full revolution is 2 pi. If we multiply that by 1/6, we're going to end up with pi over 3 radians. And remember, it's going to be 1/6 of the circle, so it's really going to be 60 degrees. If we keep going here, 1/8 of a revolution. So we would take our 2 pi, we would multiply it by 1/8, it's going to be pi over 4. So what's pi over 4 in terms of degrees? 45. 1/8 of 360. And finally, with the 1/12, we would take the full circle times 1/12. Well, 2 pi times 1/12 is pi over 6, which means that we're going to have 30 degrees. Yes. So as we finish today, let's just summarize. So the first thing that we really had to refresh were the quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. If we're measuring here with a positive angle, we're going to go counterclockwise. So we want to put an arrow in that direction. And what we started with a couple minutes ago is full circle. How many radians is full circle? Well, it's 2 pi. Well, then we did half of a revolution, and we said that half of a revolution was pi. Well, then we did a fourth of the revolution, which was pi over 2. I wonder if we could figure out what this radian value is down here. Well, we actually went here. We went 1 pi over 2, then 1 pi. This is 2 pi. This must be 1.5 pi, which is really 3 pi over 2. By the way, we really could have started here with 0. And I should have. 0, going around, and then going full circle, ends up with the 2 pi. In other words, what happens here is that quadrant 1, our angles are going to be between 0 and pi over 2. In quadrant 2, our angles are going to be between pi over 2 and pi. In quadrant 3, our angles are going to be between 3 pi over 2 and pi, and pi and 3 pi over 2. And in quadrant 4, then they're really going to be between 3 pi over 2 and 2 pi. If we want to go back and put those in degrees, then we can say that our angles are going to be between 0 and 90 degrees. And in quadrant 2, we're going to go from 90 to 180. But 90 is still quadrantal, and 180 is still quadrantal. Then in quadrant 3, we're going from 180 180 270. Again, 180 is still quadrantal. 270 is still quadrantal. And then here, 270. 360. 270 still a quadrantal. 360 still a quadrantal.